Good day, everybody. This is Dr. Nandi. Today we are going to talk about how to find the limit. Okay. So I'll share my screen with you. Limit, a simple explanation. Problem, find this. So finding the limit is similar to or boils down to find the slope of the tangent line at point P on the graph of y equal to fx. So I've shown the curve y equal to fx. I've located the point P, which is the x coordinate of C and the y coordinate of function of C. Okay. It is to find the slope of the tangent line at the point P, we will approximate this slope using a secant line, which is a line drawn through P and another point Q on the curve, which has a coordinate of C plus delta x coordinate and y coordinate of function C plus delta x. Okay. So slope of the secant line P and Q, where P and Q are 2 points on the curve y equal to fx, is m is y2 minus y1 divided by x2 minus x1, which is change in y divided by change in x. So m, or slope of the secant, m secant, is equal to y2 is f of c plus delta x, that is the value of the y coordinate at the point Q minus the value of the y coordinate at point P, which is fc, divided by x value at Q, which is x c plus delta x, minus x value at point P, which is c. So it finally reduces to slope of the secant line is equal to f of c plus delta x minus f of c divided by delta x. So we define the tangent line with slope m. If f is defined in an open interval containing c, okay, and if the line limit, okay, delta x tends to 0, okay, that means change in x tends to 0, delta y by delta x is given as limit delta x tends to 0, f of c plus delta x minus f of c by divided by delta x is equal to m. Okay, remember that is the slope of the secant line. If that slope exists, then the line passing through c f of c with the slope m is the tangent to the line, the tangent line to the graph of f of x at point c f of c. So if that limit exists, then the line passing through c f of c, okay, that c is the x coordinate, y is the f, y coordinate is fc, with slope m is basically the tangent line to the graph of fx at the point c of fc. How is that possible? Now, we started with a secant line. So I've shown you a secant line in the left-hand side diagram. The p coordinate is c and fc, and we incrementally increase delta x and delta y to reach q. Okay, so change in y is delta y, change in x is delta x. So p and q are 2 points. Now, as we make delta x very small, as delta x tends to 0, the secant line becomes the tangent line at the point c of fc on the curve y equal to fx. So it's a tangent line approximation. So what is the definition of the derivative of a function? The derivative of function fx, the derivative of the function of fx at x is given by f prime of x, f with a line at the top, slanted line, f prime x is equal to limit delta x tends to 0, f of x plus delta x minus fx divided by delta x, provided that this limit exists. For all x for which the limit exists, f prime is a function of x. The process of finding the derivative of a function is called differentiation. So we first started with to go over once more, first we try to find the limit, which is the similar to finding the slope of a tangent line at point P on the graph of y equal to fx, okay? So the slope of the secant So we cannot find the slope of the tangent line right away. We have to find the slope of the secant line joining 2 points on the curve, which is given by f of c plus delta x minus f of c divided by delta x. Okay. And now we define the tangent line with slope m. What do we make? We make the change in x very small. So limit delta x tends to 0, delta y by delta x. This is the slope of the tangent line, is given by f of c plus delta x minus f of c divided by delta x, with delta x tending to 0. And that is the slope of the tangent line, okay, in an open interval containing c on the curve. Okay, so that is the slope of the tangent line, okay, through c f of c. And from the secant line, we make the delta x very small. We reach the tangent line, which touches the curve at only one point c of fc, the curve being y equal to fx. Okay, and from that, we define the derivative of the function. Okay, derivative of the function is given by f prime x, which is limit delta x tends to 0, the value of the function at x plus delta x minus fx divided by delta x, provided that this limit exists, then derivative of fx is given by f prime x. And the process of finding a derivative is called differentiation. So now you see how limits, slope, and derivatives are tied all together. If you have any question, please write me a comment. If you like this video, please hit the right like button, and please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I'll come back again with another problem. See you next time. Take care. Have a nice day.